Okay, so once again, we are going to look at trigonometric ratios involving 30 degree, 45 degree, 60 degree, and anything that goes beyond that. We are going to look at finding the exact values of trig ratios that will have its angle going between 0 degree to 360 degree. Not just 30, 45, and 60. But what if we have an angle that goes all the way to the second quadrant, the third quadrant, or the fourth quadrant? How do we find the exact value for these angles in standard position? And how do we use their reference angle to simplify the work? So here in example number 1, we have a point 8 and negative 8. Here is 8 and here is negative 8. This point on the graph will now give us a terminal arm. And this terminal arm will give us an angle in standard position going from 0 degree, the positive x-axis, going counterclockwise to get to this terminal arm. Even though we have an angle that goes bigger than 90 degree, this angle in standard position is 315, I can use the reference angle to find the sine ratio, the cosine ratio, and the tangent ratio. Because technically, this terminal arm will still be able to create a right triangle for us. Using the coordinate 8 and negative 8. These two numbers will give us the length of the opposite side and the adjacent side. Now, of course, it sounds a little bit weird to have a negative 8 for a side length, for the length of this triangle. But we are going to hang on to this for now and calculate the hypotenuse of this right triangle. Using the hypotenuse of this right triangle, we can then calculate the sine ratio and the cosine ratio. Both of them will involve the use of hypotenuse. So here, the length of the terminal arm, which is the line from here to there, can be calculated using a squared plus b squared equals c squared. And now hopefully you can tell why it doesn't matter to have a negative 8 for the side length. Because as you square the number, the negative number turns positive, and therefore you will still end up with a positive value for the length of the terminal arm. Square root of 128. Now, of course, you can probably simplify this radical. When it comes to the final exam, please make sure you simplify your answer. You can use a factor tree to simplify this radical. Or using the concept we just did, knowing how this 128 came from 64 plus 64, or technically 64 times 2, taking the square root of this number means the same thing as taking the square root of this times that, giving us 8 times root 2. So this would be the length of your terminal arm. And using the length of this terminal arm, or the hypotenuse, I can now calculate the sine theta in this quadrant. Here is your sine theta using this reference angle. This angle will have an opposite side of -8 divided by its hypotenuse, which is the length of the terminal arm. -8 for the opposite, and 8√2 for the hypotenuse, and that will simplify to -1/√2. At the 8 reduced at the end. This value looks very similar to the one we saw in the previous lesson. Sine 45 degree does give us 1/√2, but that's when you have 45 degree in quadrant number 1. In quadrant number 4, because we are now dealing with a different angle, 315 degree, this angle in quadrant number 4 will give us a different sign, as you have an negative for its opposite side. And that's why if you try to use your calculator and find the value of sine ratio, anything between 270 and 360 degree, if you have a terminal arm anywhere in this quadrant number 4, the sine ratio on your calculator will give us a negative ratio. Okay, so once you have, if you have time, you can probably get your calculator to calculate, let's say, sine 300 degree, or sine 289 degree, or sine 345 degree. All these angles between 270 and 360 will give us a negative ratio for sine theta. Using the same concept, I can now calculate the cosine ratio. The cosine ratio in this quadrant involves the use of adjacent and its hypotenuse. Cosine ratio would involve the use of adjacent and hypotenuse. And it basically will involve the use of the x-coordinate of this point divided by, once again, the length of your hypotenuse. And in this case, it will give us a positive ratio. Sine ratio and cosine ratio will give us either a positive or negative, depends on which quadrant you are dealing with. In quadrant number 4, your cosine ratio would involve the use of adjacent, which is always on the positive x-axis, and therefore your ratio will always be positive. Your hypotenuse will always be positive as well, and that's why it wouldn't affect the sign of your ratio. In this quadrant, the tangent theta would involve the use of opposite over adjacent. Knowing how we must have a positive ratio, we have a positive for this adjacent side. Here is your adjacent on the positive x-axis. The sign of this tangent ratio will now depends on the opposite, which is now having a negative value, because the line opposite to this reference angle is now -8. We have -8 divided by 8√2, and that will simplify to -1/√2. And that means in quadrant number 4, in this quadrant, the sine ratio and the tangent ratio will Wait. Yeah, I got it wrong. Thank you. Yeah, it doesn't make sense to me. They shouldn't give us the same value. -8 for the opposite and +8 for the adjacent. Yes, so that would be -1/1 or technically -1. And once again, in this quadrant, as you can see, both sine theta and tangent theta will give us a negative ratio. Only the cosine ratio will give us a positive value all the time. Because in this quadrant 4, the one that involves opposite will give us a negative ratio all the time. Any angle between 270 and 360 will give us a negative for its opposite side.